All right, everyone. Good to go? Cool. So tonight we're going to be going over basic visualizations in Python. Real quick, I'm going to get a show of hands for who attended the previous workshop with GW data. So basically everyone got like 3 or 4, so that's great. The workshop that this builds on closest is the exploratory data analysis workshop we did in pandas. So if you recall, we went through pandas and we learned how to ingest data, how to sort out the descriptive statistics of that data, determine what it is that we're looking at in our data set. We looked at how to deal with missing values and add new columns and basic feature engineering. Equally important to understanding your data is visualizing it. It could happen that you have a clustered number of values around one specific country, or perhaps you have very skewed data. And one of the best ways that we get to see if our data is useful to us is by visualizing it. So if we want to better understand our data and also present our results, visualization is critical to that. Tonight we'll be going over visualization in Python using the pandas library once again. We'll be operating out of Anaconda, and I think everyone that's attended a previous workshop already has Anaconda downloaded. Now, for those who did not attend the previous workshop, can you raise your hand again? You did not attend. Do you have Anaconda downloaded or installed? Yes? It's no problem with you. Yes. Yes. And I think there's one other hand. Do you have Anaconda installed? Yeah. Okay, Byron will help you out. So I encourage you all to open up this document. This is posted both in the Facebook group and circulated via email. This document describes a bit what we're talking about and the data sets we'll be using, as well as, most importantly, the code. So unlike the previous workshops, tonight's workshop is going to be exercise free. I'm just going to be running through the commands that we'll be using within Python. And the thing about visualization is it's a question of understanding the functions that are available to you, less than it is understanding exactly ways you can blend functions together. So when we did web scraping or when we did exploratory data analysis, there's some bit of challenge in human input to saying, maybe I just want to grab this feature from a web page, or maybe I just want to explore this column. And there's a bit of interactivity. With visualization, it's kind of like, well, how do I do a histogram? How do I do a bar plot? And those types of questions, which are pretty descriptive, right? So there's not many challenges associated with tonight, but instead just a rundown of the code that I posted here. Before jumping into that specific code, however, I want to touch on the other visualization technologies that are available to us as data scientists. Python is a great place to do data analysis and also a great place to build some basic charts and graphs to check our results, but it's not necessarily the choice place for visualization, especially for presentation of ongoing results. An example would be Tableau, if you've known that software technology, or D3.js. And for those tools, there's also actually a tool from Deloitte that I've posted in this doc here. So I just want to touch on these for a second so you're aware of them. The first one is D3.js. It's a library in JavaScript. So I encourage you all to visit this website. The great thing about D3 is it's an easy way to view interactive charts, plots, graphs, etc. So head on over to the examples, and that takes you to this GitHub profile. Within that GitHub, you can see all the amazing graphics that you can produce using D3. And each of these would be interactive. So for an example, if you mouse over, you can see them changing based on where your mouse would be. And there's really an infinite ways that you could use these graphics to explore different amounts of data. An example that I really like from D3 is actually Dropbox has posted an example of what their usership is like, which cities are most likely to be sharing. I'll bring that up for you. Or I'll find it during a break, frankly. I don't want to waste time going over finding a specific link. The value of D3 is being able to mouse over
specific graphs. And whenever you see, values populating from a specific chunk of a bar chart, et cetera, D3 is a great way to implement those types of technologies. There's also this Deloitte free software you can use. This is one that we learned about at the employer workshop that GW Data hosted. I've personally never used it. I understand that it's can be a powerful tool based on the analysis you're doing, but I want to put it on your radar in case that's something you want to play around with. The last one is Tableau has a public option that you can use for visualization. And Tableau is a famous company for doing data visualization technologies, producing dashboards, interactive displays of our data. Kind of like if you're familiar with pivot tables in Excel, it's pivot tables on steroids. And that's a great use of technology there. So let's go ahead and jump into the code that I circulated. So fire up your Spider. And as I said, because tonight's code is predominantly running different lines and seeing how things work, I encourage you to go ahead and copy and paste everything that I've posted to my GitHub repository into your own local machine. We'll run the two side by side if you like, because the experience of typing out what each of the command lines do can be valuable. Nonetheless, shouldn't be hard to stay up with exactly where I'm at, given you have all the code here and can copy and paste easily. So we'll be using pandas. Because pandas has a number of powerful tools for producing just basic graphs and such. So if you remember, we always import pandas, and the convention that's nice is calling pandas PD, because then whenever we make a call to a function within the pandas library, all we have to type is PD. So import pandas as PD real quick for me. And then also import the matplotlib, please. And I import it as PLT so that whenever I make a call to Mathplot, I just say PLT dot something, right? And then I also run this line here, %sign matplotlib inline. This makes it so that whenever you produce a graph, it's going to come up in my console space rather than an external window popping up. And this will depend a bit on what version of Python you have. This is true for version 2.7 or 2.x really, 2. Anything. If you have 3.0, it may still appear in a different window. Not a big deal, just a personal preference. Let's also increase the font size for easier viewing, right? So the command there, plot rc params, and then figure.fig size. I made mine 8 by 6. Font size 14. So nothing too exciting again so far, right? We're just importing our libraries. We're telling Python what we want to do or how we want it to produce our graphics. So now we have, what have we done so far? We've just simply imported pandas, an open source library for data visualization and exploratory data analysis, basic data manipulation. We've imported matplotlib, a nice way to make plots. And we said we want to make our figures a larger size in the font size 14 by default. Pretty straightforward. Now let's bring in our data. And before I bring in my data, in my code here, you'll notice that I made this. Can someone tell me what line 23 is doing? What is happening if I run this line? Yeah, I'm making a list of strings. That's exactly what I'm doing. And my list of strings is called drink_calls. And we'll see why I named that in a second. And I called each string, the first one's called country, beer, spirit, wine, liters, constant. So I'm going to make that, just make that little string, right? So interestingly, right, because that's just a list, I can call a specific value in that list. So if I were to do this, can someone tell me what would appear? Not the same person? Spirit? Why? Did everyone hear that? Why does spirit appear and not beer?
because we index at 0 in Python.
Right. And you're right. From my list of strings, I called the value at the second place, and it says spirit. Cool. So what I'm also going to do is I'm going to import data, but before I import data, you notice that I'm doing this. What am I doing here? Whoever someone went off, you have to answer this question. What am I doing on this line? No worries. Anyone else? Defining. Yeah, I'm just defining a variable called URL. So, and the URL is the location of our data. If you return to our sheet, right, that's the first data set that I said we should use. It's right here. So I'm going to declare that. So now I have a variable called URL. And that's what URL contains. Now, I'm going to make something called drinks. And it's going to use the pandas library, right, to read a CSV. The CSV's location is URL, or in other words, this string. Header is 0. Names equal drink calls. What's happening there?
You're naming the columns based on the scope of time in the day in your list.
Yeah, exactly. So if I did not say name equals drink calls, the name of the columns are going to be whatever it inherits from the data, where the data was posted. In doing this, I've made it so the column names are going to be the drink calls that I've defined above. Because if you were with us previously, you understand that this drinks data set, the column names weren't actually very conducive. They were quite long and they included spaces. It was something like number of servings, number of liquor servings, number of wine servings. And just by renaming those columns, so I obviously know where number of beer servings was the first column as per Python indexing, number of spirits or amount of spirits was this column, and so on and so forth. I knew that when I defined which variable or which string was going to appear in what order. I knew that my drink columns data set I'm importing had beer in this column, spirits in this column, wine in this column. So I could generate a variable called drink calls, where instead of number of beer servings, it's just beer. And that will make it easier for us to refer to those variables down the line, or those columns rather. So like if I checked out the raw data, those that are confused, you'll see here, that the names of the columns were not very conducive. So they didn't have spaces. I was wrong, I forgot. They just have underscores and they're very long. So by naming those names, as you pointed out, I'm now renaming beer servings to just beer, wine servings to wine, and so on. So that's what this is doing. Now what is this? NA filter equals false. You almost had to have been at a previous session to understand why this is important for this data set, but nonetheless, the majority of us were. So can someone tell me why I have NA filter false? What does that mean? Yeah, so if you're with us at a previous session, you recall that this drinks data set had North America abbreviated as NA, right? So all these instances of NA, 39 of them, are all going to be imported. Well, I suppose not, of course, ones that appear in continents like Canada and China. But nonetheless, long-standing NAs would have been imported as null values. And that's because Pandas is smart. Pandas doesn't assume that journalists are making our data sets. Pandas assumes that data scientists are making our data sets. And when you use NA, you're saying that there's something null. So that's a little stab at the journalist that put together this data set, right? Using NA for a value. But by saying NA filter false, I'm saying don't replace NA with null. just leave NA alone. Now, you might wonder, how did I know that NA filter false even existed? Like, how is that something that I could call? Like, how did I know that names was something I could call? How did I know NA filter was something that I could call? That's because there's documentation for every single, well, majority of highly used libraries in Python. This also explains why it's really important to document your code should you ever make an open source contribution. This pandas documentation tells us what is available to us. So tonight, I mean, I'll be using a lot of the visualization stuff. When I'm importing values, it's all here, right? So knowing the power of a library is either you have someone show you, hey, these things exist, or even better, you read documentation, which is why it's, again, very important to document your own code, but also find libraries that are well documented. The same thing is true for APIs. If you ever go to an API, you need good documentation to know what's going on. So let's go ahead and do that. Run that line. So you'll notice in my variable explorer, my cheat sheet for what just happened, I imported a data frame, right? So you guys good? Great. So I imported a data frame with the data that was available in this raw CSV. So right, I can call a specific column by just referencing its name after the data frame with some quotes. Remember this with some basic exploratory data analysis stuff? So now we're going to be doing calls that Pandas makes available to us as a library that will help us visualize our data. I want to produce a histogram, okay? So to produce, what is a histogram? First and foremost, what is a histogram? Bar graph with no spaces between the bars. And why are there no spaces between the bars? What's special about a histogram that's different than a bar graph that has no spaces between the bars? Continuous. The values on the y-axis are numerical continuous values. Okay? So if I'm going to make a histogram, what are the features of a histogram? What does a histogram have? It has an axis, an x-axis, probably there's a y-axis too. What else does it have? Bars, right? So those bars, we can say how many of those bars called bins we want to be produced. And we'll walk through how to do different numbers of bins in a second. So if we're producing a histogram, we also want our values to be sorted largest to smallest, right? Because can you imagine if you plotted, we're so used to seeing sorted histograms, we couldn't even imagine what it would look like to see a non-sorted histogram, because therefore the visualization would be largely worthless to us. Imagine if you had 86, 24, 56, 112, right? That's not a valuable visualization. What you want is 112, 86, 54. So you can just see your values in the continuous way in which they're stored in your data set. So fortunately, Pandas has the ability for us to sort our values. So that's what we're going to do. I'm going to take drinks.beer, so working with the beer column. I'm going to order the values. And it spits out, hey, here's the ordered list. And you'll note it default ordered descending. So let's make a histogram now. Now we have some data. We've imported some data, right? We've also created or sorted our data. Now, since we have sorted data and data to plot at all, we can make a histogram. The call for making a histogram is the data frame you want, the column you're using. We're making a plot. The kind is hist for histogram, and the number of bins is 3. So that's the default way of asking for a histogram from pandas.
Actually, about the previous line where you did the sort,
Yep.
did that reorder the data frame in place, or did it just return a view of, well, this is what it would look like if you do the sort of view?
It returned the latter.
Okay, so it's just like, here's what it would look like.
Yeah, and we'll go over sorting pairs once we do scatter plots.
Oh, okay, cool.
Yeah. So that's a good point. The underlying data frame has not been affected, right? Just the call we made has been affected. So when we work with beer in the future, beer will still be affected this way. And we can always import the data frame again if we wanted to return, no problem.
So if I say brings equal to bring dot here dot water dot value, then it's
You
the
have to
sorted
say-
water will go there and assign to the new brings to override it.
Can I ask what you're after? What are you trying to do?
Instead on line 29, it just displaying a value water in the beer.
Yes.
Okay? If I want to hold it in another object, so if I say brings equal, whatever is there. So if you assign this value,
Yeah, you can do that.
water, right?
Yeah. You can do that.
Say
If you,
drinks.
if you want to make a new data frame.
bracket, Beer, and so it would reorder the things in the beer column. If you wanted to do a different place. Because otherwise, notice the data type at the top, how it says array. It's just returning an array, not a whole data frame.
Right.
Not a reorder data frame.
Right.
So you could put it into another variable and play about it, but it's still separate from the actual data frame itself.
So what are we talking about here? What is this nerdy discussion about arrays and sorting? She's accurately pointed out that when we ask for this to be sorted, this column, it spits out solely that column, an array of values. An array is a data type that is a list of values that are all of the same variable type. So they're all numbers in this case. And what's significant is this is not a data frame. We did not sort the entire data frame. We only sorted beer. And therefore we got just the beer column out. That's what this discussion is. Is that? Yeah. Okay. Good question. So now if I jump in and I make a histogram with 3 bins. Oh, look at that. Made a histogram with 3 bins. It's pretty neat. And it appeared in line because I said, percent matplotlib in line. Something you'll notice is that this graph is pretty ugly, right? So this is not something that you'd want to throw into some cool presentation. Fortunately, there's a number of styles that come included with the pandas library or with matplotlib. And I've actually done that at the very end because when I made this, I was like, I want to make them suffer through and see how ugly it is before we make some pretty ones. But I'm changing my mind because it's ugly. So at the bottom, at the very bottom of this, I noted that we could see line 174. We can call plot, remember, which is our matplotlib. That's how we imported matplotlib. And we can ask for what styles are available. So let's do that. Let's say, hey, what styles are available? It says there's dark background, there's BMH, there's grayscale, ggplot, and 538. So I'm going to use ggplot. So all I did is plot plt dot style dot use string ggplot. So now let's go back up and let's remake our histogram. Ah, look at that. Now that's something that I would throw somewhere. I'd consider using that. In fact, I might even use that style for this workshop, right? So this is a scatter plot that I made of data that's actually not this. I just renamed the axes. But this is a scatter plot of ordered values of x, y pairs. And we'll make scatter plots in a second. This is also a very, very, very soft sell to coming to our workshops, right? Unless you don't want to be awesome. Whatever that is, you could be it. Your awesome coefficient could be 110. So let's do the same plot and use 20 bins. Oh, okay. And we kind of get to see some more variation in our data. And you'll notice that we're producing these graphs, but there's no axes titles. I mean, it default says degree for a histogram, because it's like, you know, the frequency of, the degree of a feature. But there's no x-axis. So, you guessed it, our next step, we're going to plot a hist with 20 bins, title it histogram of beer servings. And we're going to run these 3 lines together, right? So plot.x label, that's how you call, you say, hey, plot. I want the x label to be the following string. And I said beer service. And then for y label, I said frequency. So let's do that. And just like that, within 35 minutes, and honestly, we started 5 minutes late, within 30 minutes of coming to our workshop, you can make a histogram that actually is presentable for something useful, for any data set you have. And remember, the end product that we've created here is not solely valuable because, oh, now I have a graph I can use, but this tells us things about our data set. Whenever there's a Kaggle competition, Kaggle is an online place where you can compete in data science competitions to build better models than other nerds trying to build better models than you. One of the best, most important things you do at the onset is understanding what's in your data set. So basically, every data scientist that competes first imports their data, does some basic EDA with just quantitative stuff, and then they'll visualize it because they want to know what their data set contains. Same thing here. Even when you're the one collecting the data, you will still be surprised by the distribution of your values. So I'm not sure how many people are hockey fans, but like I like doing hockey analysis in Python, and I'm perpetually amazed by how bad the Toronto Maple Leafs are. Like they're just like off the charts bad. And no one here is a Toronto fan, I guess. Fortunate, I don't like them. So the next thing that we're going to do is produce a smooth version of a histogram. So like a density graph, right? So what is a density graph? Don't cheat and run the line. Tell me, what is a density graph? Or cheat and run the line and then tell me. Smooths out the curve. So I say, again, I'm going to plot beer. So drinks.beer.plot kind density xlim. What do you think this is? What do you think xlim is? What am I doing there? Yeah, it's in the range of the x-axis. Pretty intuitive. Yeah, kind of neat. As a data scientist, which do you think is more valuable for this data set? Why?
It actually gave you more information because as a density, it's sort of the y-axis on it's changed to be sort of a fraction of the percent of the whole. whereas the other one, you actually got the raw counts. So I know that there are this many people that had 0 beer, et cetera, et cetera. I can actually read the raw data back off the graph if I need to.
Exactly. Did everyone else notice that? The y-axis is now, as she said, accurately said, the amount of our data presented as a decimal form that appears based on each height or each number of servings of beer. So can someone think of an instance when a density graph may be more useful than a histogram? Maybe within your own projects.
When something clearly follows like a normal distribution or something that's like very lopsided.
Exactly. So if something's following a normal distribution, you'd expect the density at the center or around the center, if I were to sum up the middle block, to be nearly approaching half, right?
So now we're going to do scatter plots.
And what is a scatter plot? Yeah, mapping individual data points by x and y, where x and y are two separate variables, right? Because it's not insightful to see a relationship between a variable and itself. It's just a linear 90-degree line. So in order to plot a histogram, we need to sort our values by one of the two variables we're measuring. But you'll note, despite sorting one of them, I'm calling two columns. And this gets back to the discussion that we had a moment ago. When I called just beer above, and I said sort it, it would output an array, and just an array of beer. The data frame itself did not change. So, to work with two values concurrently and sort one while using the other, I need to ask the data frame for both of those columns and just sort by one of them. Right? So that's exactly what I'm doing here. I'm asking for beer and wine, and I'm sorting by beer. So, what am I about to plot? Like, yeah, we can just run through this code and just, oh, look, pretty graph, pretty graph. But what am I doing right now? From this side of the room, I've heard more from over here. What plot am I about to make? Andy, I know your name, you forget. Yeah, exactly. I'm looking at the relationship between beer and wine consumption. When X amount of beer is served, Y amount of wine is served, and so forth for my entire data set. Exactly right.
So let's go forth and do that. I'm going to do drink stop plot, kind, to call for a scatter plot, I call scatter. And the X is going to be beer, and the Y is going to be wine. Something significant about this plot, or this call, the variable names that you name your X and Y need to be the data frame column names. Right? I mean, that's pretty intuitive. The data needs to know which column it's calling. By calling on beer and calling on wine, I'm telling the data frame I need both of these columns. So when I made this really unuseful thing, I had to rename my very useful. Come to more workshops. When I made this X and Y, I had to retitle my data frame, which, spoiler alert, it was about hockey data, with hours spent in Python with GW data and awesome code. I forgot what variables I used for that. I remember the y as points, so the number of team points someone earned. Okay, so then let's go ahead and do that. That's kind of neat. Scatter plot. I mean, it seems like there's not a great correlation that we can see. I mean, somewhat, the amounts increase together. That's not totally random. The amounts generally increase together, but it seems beer increases at a higher degree than wine, so they're not exactly one-to-one. Now, what's something that's problematic about this graph? There's a few things, but name one of them. It's not a strong correlation. I don't know if that's problematic about the graph per se. That's if I were a data scientist and I thought there should be a correlation here, it's problematic for my assumptions for sure, which is actually something that's valuable about visualization. But if you're looking at just ignoring anything about the data set itself and just looking at this graph, there's something problematic probably in this region. Do you see what I'm getting at?
Can't tell how dense those points are.
Can't tell how dense those points are. There's a lot of overlapping points here. So I don't really know how many there truly are here. Fortunately, we can use a density coefficient for the color scheme. And we could say the alpha, the amount of color that is applied when points overlap, right? So the more overlapping points there are in a single place, the darker we'd expect the region to appear. If there's a single point standing by itself, it will appear as the alpha coefficient darkness of the total. So that terminology was non-coincidental with the way that you call for a color scheme. So I'm going to do the same exact thing, except I say alpha is 0.3. So what am I saying? How dark is a point that's going to exist with no other overlapping point? I'm going to ask you that. Exactly. Exactly. A single point existing by itself, so like any of these guys, are going to be 0.3 dark of the hue that you see of blue. So in other words, if you had just this blue point and you applied an opacity filter of 70% white, like in Photoshop, that's what color this point would appear. So let's do that. And just like that, each of the points that exist by themselves, largely light, and the ones that are overlapping, it gets darker and darker. So now we have a better feeling that, man, there's a cluster right here. And now, Isaac, I'm going to ask you, because you brought up good points about our data set itself, what does this mean in the context of the data set we're looking at? And then why do you think that looks like that? So if there's a lot of points here, just like, what does that mean, first and foremost? Yep, and then, yeah, so you see a lot of overlapping points at 0. In the context of our data set is continents and how much, or countries rather, and how much each of those countries consume beer and wine. So what do you think that means about a number of countries in our data set?
Either the data is missing or they don't consume any beer.
Exactly. You hear that? So this is the point of visualization. It's not to make pretty graphs. I mean, sometimes it is. The point of our visualization is to tell us more about our data set and better synthesize what we're looking at to look for reasons why our conclusions are the way they are. So before coming in here, you probably knew, there's some countries that don't consume beer or wine at all. But
you would forget knowing that and how much that would impact the data you're looking at when you're perhaps trying to explain causal reasons why some countries consume a lot of wine and beer. By seeing right here in your face that there's a lot of countries, so many so that there's a dark point, that consume 0 wine and 0 beer, we can think, oh, well, maybe now when I do some analysis to explain the amounts of beer and wine, beer or wine, maybe both, that a country consumes, I should omit those where it's 0, because those are really skewing my data set when I'm trying to explain how much beer or wine is consumed in the first place. So that's like a useful takeaway we could derive from a simple graph.
Now, here's a cool thing. I can add in a third variable, default C, and choose a color scheme that is available to me. I know that blue map is available, and have it show the colors of each of these points, plus the third new data point observation we're looking at with the color scheme blues. So I've now plotted 3 variables at once, right? It's kind of confusing, maybe not a very useful graph for showing results, but perhaps a useful graph for thinking about our data itself. This is beer, right? This is wine. And how dark a point is spirit. So now we have a scatter plot of 3 points, a 2-dimensional scatter plot of 3 points. Just a useful trick, I suppose. And I can also do a scatter matrix of 3 numerical columns. So much like I just produced a single 2-dimensional graph of 3 data points, perhaps it would be more useful to see those 3 data points on a bunch of independent XY graphs. In other words, I'm doing 3, choose 2 number of graphs with 3 variables. So if you're familiar with combinations and permutation theory, right? If I have 3 variables and I can only put 2 on a graph, there's a few different ways, depends if you're in a permutation or combination, that I could plot those 3 variables with just 2 of them together. And then I can make that in a matrix. I can make those independent multiple 2-dimensional graphs in a matrix. So I think after I make this, it'll make a lot more sense of what I'm talking about. So you see that? I've made a matrix of beer, spirit, and wine, where here's spirits against wine. Here's beer against spirits. And you'll notice when it does spirit against spirit, it knows to not just make a scatter plot of a 90-degree angle. It makes me a nice little histogram. Kind of bar graph. Bar graph. Technically histogram. So just like that, I've made a bunch of scatter plots at once. And so if I were checking for correlations in a data set of 3 different variables, and I want to do it quickly, there you go. So we can see immediately which ones have better causal relationships and which ones don't. So you'll note here, this is beer against wine, which uncoincidentally, we actually just plotted except beer with the x-axis, right? But it kind of hammers home how much these cluster along beer increasing without wine increasing much to match, right? Seeing it vertically drives it home that much more. And I can do that same thing, but I can make it bigger. And because I'm plotting in line, it doesn't appear bigger for me. But if I saved the figure locally, which I will show you how to do, it would be a larger figure. Is anyone plotting not inline? Is anyone opening separate windows every time they're making a plot? DF 3.0?
No, just give me an end.
Huh.
Because what the 3.5.
Yeah, what's the big one? I don't know.
Okay. The TA is getting TA'd. Do we have questions at this point?
Do you like a particular graph or a particular page so the question is, if I have a matrix of outputs and there's one specific quadrant that I really like in my matrix, yeah. Can you undo the inline? What I would do, I don't know for sure. It's easily undo inline. There's probably in the documentation a way to say inline false to turn it off real fast. I don't know off the top of my head what I would probably do. This would be inefficient. I could probably just look up the documentation of how to turn inline off. I would save it and then just open it up in a separate window. That's inefficient. But answer the question, no, I'm not familiar with how to immediately turn inline. There's other whispers, and people are just commenting on stuff. Do you have questions? Too fast, too slow, intuitive? Thanks. Too fast, too slow?
I on my code plotted a scatter plot that looks at, like, let's just say here there's a spirits for countries in a specific continent.
Yeah. So you want to do just one continent.
Yes.
So do you remember, were you at the Pandas workshop?
Yes.
Do you know how to ask for just one continent in a data frame?
So,
If I do drinks and I say round brackets.
oh, that's
Yep. Yeah. Is that what those are? English. Am I right? So parentheses. Single quotes. No corrections yet. Continent equals equals.
oh, and it's good.
Yeah, it's Boolean. And then you're working with your data frame just continents when equal to NA. Then after that, call from within that data frame spirits, and you said you wanted wine, so or spirits and beer, whatever. Then the same bits here. Okay. So in other words, the question was, how do I limit this to one continent? Well, you'll notice that line 46. Line 46 is calling for beer and wine from all of drinks. We know from a previous workshop how to ask for just a specific condition from a data frame. So we can insert that condition right there, right after drinks. So it says drinks, parentheses, when continent is NA, and then this. So I'd only be looking at values are NA for beer and wine. Good question. So now, were there other questions? Cool. This side of the room's kind of quiet. Is it too fast, too slow? Fine. Just quiet. Fine. All right. It's great. One word. All right. So now we're going to jump in and do some bar plots. For these bar plots, now getting back to the core of the difference between a bar plot and a histogram, what can you do in bar plots that you cannot do in histograms? Categorical variables against another categorical variable. Or multiple categorical variables, perhaps, because you can do clustered bar plots, things like that. So when you're working with categorical variables and you're working with more than one categorical variable, you will need to do a bar plot. So I'm going to start working with a categorical variable here. And I'm going to do continent. So first and foremost, I want to know how many of each continent I have. So I have 53 notices of African continent. Or in other words, 53 countries, right? So neat. Now, I'm going to do that same thing. I'm going to call for a value count, except I'm then going to tell it to plot kind is bar, right? So drinks.continent.value underscore counts, parentheses, dot plot, kind equals bar. It's exciting. So that table has a bar graph. Now, what if I wanted to do for each continent, I'm going to do continents and the mean alcoholic consumption on each continent, and then I'm going to plot that as a bar graph. So in other words, how much alcohol, the average amount consumed in Africa versus the US or North America, South America, so forth, as a bar graph. So I mean, if I do that, these are the values that I would be expecting. Likewise, so first and foremost, this gets at the core of visualization. The second you see this, and if I were to ask you which continent, order the amount of spirit consumption by continent, you kind of have to like, oh, okay, let's see. First we got North America, then we got EU, then we got South America, Oceania. Oh no, Africa, Oceania, right? So the value of a bar plot is all that information immediately delivered. So it automatically knew the cluster by what we told it to, constant, and the amount for each. So we said group by continent, mean, plot, bar. So when we did the mean, you'll notice that Python automatically knew to take the mean of all numeric columns in our data frame, right? When we said mean, we didn't have to say mean of beer, mean of wine. It just knew. If we said mean, we're working with numerical values. That's really nice. Thanks, Python. So, skipping it out a bit. Well, no, okay. So if I wanted to do the same thing, but I didn't want, liters. By the same token, remember if I do the mean, it's going to do every numeric value. And if I wanted all but liters, I could call for all of them or just drop liters. So that's what I did here. So that brought up a significant thing about this bar plot, right? It included all numerical values, including liters, which doesn't make a whole lot of sense to be measured against the amount of servings of beer, spirits, and wine. Because returning to our original data set, oh yeah, that was total liters of pure alcohol, right? Doesn't make a total lot of sense to measure that against the others, given it's going to be dramatically lower no matter what. So we dropped it. Oh, and then I can also make
the least useful graph in the history of graphs, a stacked bar plot.
Don't ever make these. But here's how you do it. Same thing. Kind is bar, stacked equals true. So what's going to happen?
What's going to happen? Yeah, these are going to come on top of each other, which is going to make it excessively difficult to tell how much there's a difference between each bar. So if you want to be a journalist, you need to know this. You need to know this. And I really hope some people like studying journalism and really angry. But there you go.
All right. So that's actually like the core of the things that I really wanted to touch on. We're going to go over some box plot stuff and some other assorted functions, how to save things. But with the knowledge that we've covered thus far in the first hour, you're set to actually be able to deduce what's in your data set and perhaps visualize some of your results. So the next thing that I jumped into was, you remember we had describe and we had values and so forth when we did pandas. So I gave us a quick refresher here, just in a comment of the 5-number summary, right? We get the 25% amount, 50% interval, 75%, and so on. We also know what outliers are, right? Quick refresher. We take the interquartile mean arbitrarily, 1.5 times it. You're above it, you're below it, you're an outlier. Everyone know the mathematical definition of an outlier? Yeah. Cool. So that's requisite for knowing the value of a box plot is an outlier and so forth. So I'm going to do this with spirits. I'm going to order my values. Drinks.spirit.order.values. Then I'm going to describe. All right. So here's the 5-number summary. Count the number of values, the mean, standard deviation, the min, the max, and the range, 25, 50, and 70%. Now I can visualize this easily using a box plot. So similarly, drinks.spirit.plot. This time I'm going to call for kind is box. Pretty neat. Box plot. And I could do the same thing with multiple variables. And Python, again, automatically will only do this with the numeric values you're working with. So just like last time, I wanted to drop liters. Total liters of pure alcohol didn't make a lot of sense juxtaposed to my wine, spirits, and beer, right? So I'm going to drop liters and make a box plot of all the other variables. So what are we going to see? Nope. 3 box plots. And what are they? Beer, spirit, and wine. Solid. It's like a sidekick. So, yeah, sorry, I should have. So we have the 50%, 70%, the max without it being an outlier, and then outliers. So an interesting thing about, the interesting thing about these values is that they're a large number spread apart in a single data set. Basically, is what we can deduce from this, except for wine. Wine, it kind of seems like we probably have a cluster down here and a cluster up here. So we can kind of deduce that. So we can do line plots as well. Now we're going to jump into doing line plots. And we're going to use a new data set. And the data set we're going to use is the UFO spottings. So I guess I lied. If you were here before, it's not new, but it's new to us today. So the source for that data set is, again, in the document that I passed around. It's here, the UFO data set. Yep, so I'm going to make a variable called URL with that URL. And I'm going to read in that CSV with a data frame called UFO. 2 key steps. Here's something that's very neat. I believe we had questions about this last time, actually. In my UFO data set, sorry, we should look at the data set in its raw form at the very least, so we have a rough idea of what we're looking at. So in its raw form, and remember an alternative way that I could do this, in the raw form, I have city, colors reported, shape, reported state, and the time that it was cited. Right? Same thing here. City, colors reported, shape reported, state and time. So time is imported as just I believe, a string at this stage. So pandas, being pandas, has a way to convert that column to date time format. So I'm going to say UFO, I'm going to call for the time column, so UFO time equals PD, so calling for a pandas function, to date time, UFO dot time. So I'm replacing the column in my data frame UFO with time being converted to a date time format. The next thing I'm going to do, the time-intensive function. I'm going to do the same thing with year. So year equals UFO dot time dot date time dot year.
This is actually very new column.
I think there's already a column called year. Is there not? Is there not? No, there might not be. No, there's not. There's not. You're right. Yeah, so it's not replacing a column called year. We're creating a column called year. Good catch. So if I bam, time and year. Okay, so right, time and year. So now I want to count the number of UFOs reported each year and then sort by year. So UFO, the data frame we're working with, year, the column we want, the number of each year, and then make that the sorting index. So it tells us, how many were appeared in each year, because that's the value count piece. Cool.
Again, does that just return the sort index as a list, or is it actually changing the contents of data frame?
It has changed the data frame it has changed the data frame, but not irreparably. So for example, the underlying data frame year column, we did not do anything to change it when we said value counts, because that's a function that we operated on it. And then we just said that's a sorting index. So we did not change the data frame per se, but we did work with one column within it to sort by the number of occurrences within a single year. So a sort function never edits your data frame necessarily.
It's the sort of index.
Yeah.
See what it did, the index actually became the year number.
Yeah.
And then the column on the right is actually, that's the count of how many found in that index.
Right. Yeah. Yeah. You know it. So I made a plot of that. Spoiler alert. Which is, so this is showing us how many occurrences we're seeing each year. So it looks like either the UFOs are coming to the Earth a bit more, we're getting better at seeing them, people are drinking more, right? There's a number of causalities for why we're seeing a spike in UFOs. And something else that's kind of interesting, you know, in the 70s, we had a spike as well. Spike here. And then now we're just off the races on how many we see.
It's X-Files. Mm.
X-Files spike.
X-Files came out.
Yeah, people they just knew how to identify a UFO. They weren't crazier. They just knew how to identify a UFO.
And then here's another journalist practice for you.
If you want to do a plot of things that don't make sense, you could do a line plot of a value count of a qualitative variable.
So for example, I could show a line plot of the number of continents that appear in the drink data frame. Ah, that's the graph they're looking for, right? So it doesn't make sense to link together values that should not be linked. Yes, non-continuous data, exactly. These are discrete values. It's very appropriate that I'm being mean to journalists in SMPA. You kind of realize that. Not all journalists are bad. There's data journalists, right? Okay, that's enough. So something else that I could do is I could do grouped box plots. So returning to our box plot of beer, right? Cool. I can group it by continent. So that segments, all right, segments my beer data by continent.
Kind of neat, kind of useful.
Kind of both. Do all of them sorted by continent? Same thing for histograms. So returning to, if I did a beer histogram, and then I grouped by continent.
And you'll notice that the default output is a matrix of graphs. Kind of cool. You can share X values, share Y values,
Change layouts. So for this one, I did share the X value for beer, for the grouped ones by continent. So you'll notice that previously, it was kind of tough to follow
100 straight up, right?
That's challenging.
I mean, here it's like almost a line, but not really.
So I can say share X values.
So it's easier to contextualize them immediately. Straight on up. Straight on up.
Do the same thing for sharing X and Y values, so we don't have the same problem on the Y. But you'll notice that this is not always useful, of course, because there could just be a high number of
observations in a single quadrant, and it makes it tough. This is pretty useless for a few of
them. Change the layout again, right? Same thing with like formatting size. And then the last thing I want to go over is saving to a file. All you do is add plot.savefig. That's it. And then you say the name of the file and what you're saving it as. So if I run this again, right, I'm running a histogram of beer servings with 20 bins. And then if I do this, it saves it to a file. What file did this get saved to? That's the name of the file, but where on my computer is that graph? It's in that folder. So the current working directory is where this is saved. So right now it's saved in DeepGeek, which is the name of a URL that I own for hockey stats, in data. So I'm gonna have to delete that obviously, but that's important. That's where things are saved. Does anyone like hockey? Anyone? Yes. You want to join DeepGeek? I'm just kidding, but not really. You were for the NHL?
I worked for a company that runs scoring software.
That's cool. So, I mean, that is everything that I had drafted for tonight. That's it. So if we have questions about the things I went over, we can handle those. And then one other thing we can do is we can just show some of the different styles, just real quick over here. So first I'll do with questions. So if you want to save a separate plot, you can add this bit of code, savefig, with a different name, of course, because you want your files to be independently named. And you can add this after every time you make a graph. And of course, something that's important is I do all this piecemeal, right? Like I do graph, then a graph, then a graph. There's nothing that prevents you from running this whole file at once. Unless you have print written, it will only print the most recent command that you ran. But if I wanted to save a bunch of things at once, I could have this named after all of these, run those all at once, then bam, I have a file with a bunch of names. And that actually brings up a good point. It's almost like I could have the savefig be a variable that iterates maybe +1 every time it's called, right? Because it doesn't need to be a string. This could just be the name of a variable, and then it would default use what value currently is in that variable. So if you had a for loop that for each graph I'm producing, this is just named graph number, a variable called graph number, and graph number is incremented +1 every time you complete a loop, you can produce a file with a bunch of graphs at once, for example. But yeah, so I mean, to answer your question, use this little guy after any graph you produce. So how could you do that loop thing that I just described? So the way that I just described it kind of assumes that you're going to be producing a bunch of graphs with a bunch of different variables each time, right? So I could have you know, you could do, it's not going to make a ton of sense with this data. But you could have this column be incrementing each time you're going through. So let's say I mean,
This isn't going to make a ton of sense in the context of this data set. However, this shows you the concept that I just alluded to. I have an index called graph number. Every time I complete this loop, graph number increments +1. Okay, two things that are going on. Now, for X in columns, so for every column, I'm going to make a histogram. I'm going to make a histogram where column is X grouped by continent and share X is true. Perhaps I want to eliminate that stuff. So what this would do is it'd make a histogram of every column in my data set, and it would save it as graph number. Yeah, I mean, it should not have a 1 there.
it's not calling the same variable. Yeah, true. What's that? Yeah, exactly.
Yeah, so I mean, the point here is not that this is actually a useful thing that I would run, but this is the way that you would repeatedly visualize histograms of each column in your data set. So remember X, a for loop, it's going to be the first column, it's going to complete, then it's going to be the next column, then it's going to complete, and so on and so forth. And if it's saving every time, it's saving as whatever graph number I'm at. So it's just going to be 1, 2, 3, 4, and so on. Does that make sense?
Other questions? Yeah. Yeah.
It always knows to work on whatever previously created plot.
Yeah.
Most recently created.
Exactly. All right, so let's just look at what a few of these other libraries look like real quick, and then we'll wrap up. So 538 looks very similar. Pretty. What if I did grayscale? It's great. It's great. Happy with that one. And then the last one, dark background. That's if you're like making graphs at night. You like really need some night vision to look at your graphs. This is definitely a library I would use for that.
Thank goodness we have that. Yeah, so that's that. The code's posted, the video's recorded. If you guys have questions about specific data sets you're working on, happy to answer them. Because we wrapped up a tiny bit early, I'm going to circulate the feedback form and ask that you complete it before you leave. That's cool. It also includes, again, which workshop you would like to see us do next. All right, so I'm going to stop the screencast and let Byron take over.
One last question about the styles.
Yes.
Do you, and you may not know the answer to this, do you know, like for APA formatting for publication, is there a style that's like recommended or required? Or do you have to like, it depends on the publication, you have to build your own publication style?
I actually do not know what the APA style guide recommended style is. Yeah, not sure. Good question.